Hello, automation superheroes. My name is Andrew, and welcome back to Controtek Solutions Online Superhero Academy. Our goal is to bring you a series of online demos, webinars, and all the technical know-hows about smarter industrial automation. In this episode of the Back-Off Programming series, I will discuss about the IEC 61131 programming standard on TwinCAT3. On the previous episode, I showed you how to link PLC variables into the back-off I/O device terminals in TwinCAT3. Basically, the purpose of that was for the program to be connected to the physical world, such as to various field devices and actuators, or simply connecting your program with the hardware. The outline of the topics that I will discuss today are the following. What is IEC 61131-3? What are program organization units? Ladder logic diagram, function block diagram, sequential function chart, continuous function chart, instruction list, and of course, structured text programming in TwinCAT3. And for the rest of this video, I will demonstrate how to create POUs, some programming, and I will mainly focus on the most commonly used programming language in the industry, such as ladder logic, function block diagram, and structured text. Now, what is IEC 61131-3? It is an international standard for programming languages of Programmable Logic Controllers. It is the third part of the IEC 61131 standard for PLCs. It's prepared and published by the International Electrotechnical Commission, or IEC. Some of you are not familiar. They're the organization for the international standards about electrical, electronics, and other related technologies. The IEC 61131-3 aims to give programmers flexibility when it comes to using the hardware of different vendors. So if you know how to program those languages, it will be easier to handle different vendors because they all look like the same, and they can all implement the IEC 61131-3 standard. The programming languages that I mentioned earlier, ladder, function block, SFC, CFC, IL, and structured text, are offered in TwinCAT PLC control. To conform to the requirements of the standard, and according to this standard, a program consists of a global variable, structures, and POUs. If some of you are still wondering what kind of hardware you need, do I need an actual PLC? What kind of PC I need so I could learn or practice PLC programming? Well, if you want to do some programming in TwinCAT3, or you just want to try out different programming languages based on the IEC 61131-3 standard, all you need to do is you just download the TwinCAT3 from the back-off website and install it in your computer. That software is completely free, and you can fully use its programming capabilities. You just have to run your program on your local PC where the TwinCAT is installed, and then you can test your program, your logics, practice, and keep on improving with your programming skills. In short, you don't need any back-off hardware yet if you just want to create and test your PLC program logics. You can just sit back and relax at home and just keep on developing and testing your program. If you want more overview of the details, you can check out the episode 3 of this series where I previously discussed the TwinCAT programming software. Now let's proceed with POUs, or program organization units. It is important for me to discuss POUs before I move on with the programming languages, because all the codes that you will write will be implemented inside a POU, or program organization unit. It's best for you guys to have a clear understanding of what POUs are. So let me just open my TwinCAT3 project. So here in my PLC project located in the Solution Explorer, under the PLC project tree, these are the default folders that shows up after creating a PLC project with the standard template. We could see that the POUs folder, and when we drop that down, there's that default main program where you could start off your programming. Now, there's 3 types of POU. We have programs, which is this, the main program over here, function blocks, and functions. And Each of those POUs, they consist of a declaration part and a body. The declaration part, which is the upper window, is used for the variable declarations, either in text-based or tabular form. So this is where you declare input variables, internal variables, and output variables, and depending on the setting. The body is written in one of the IEC programming languages, which include IL, structured text, SFC, function block diagram, ladder diagram, or CFC. In here, in the main program, the implementation language is structured text by default, but TwinCAT PLC Control supports all IEC standard POUs. And if you want to use these POUs in your project, you must include the library standard.lib in your project. Let me start with the program. So a program is the highest level of POU. A PLC project should have at least one main program POU. That's why after creating a PLC project, we'll have a default main program. The program returns several values during operation, and programs can read and write to other input or output variables and can communicate with other programs and also recognize globally throughout the project. All values can be retained from the last time the program was run until next. Programs can also call function blocks and functions. Next is a function block. A function block is a POU which provides one or more values during the procedure. As opposed to a function block provides no return value. So let me just add the function block here in the POUs folder. Right click on POUs folder, then select command add POU. Enter the name. I'll just type in sample_FB. Then next is select a POU type as function block. Then select an implementation language. You can see that here are all the available programming language for my function block. I'll select ladder logic or LD, then click on open. Now I have added a new FB in the POUs, and now we could see that the upper part window is for the declaration area for the local variables of this sample FB. So I can declare input variables here between the keyboards var_input and end var. So for example, I'll declare a bstart as a boolean data type and a bstop as a boolean data type. So these variables are the input variables of my function block. For the output variables, it can be declared here, and for example, I want to declare a b running boolean variable. And for the internal variables of the function block, you can declare it here between the keywords var and end_var. So these variables will not show up as an input or output when you use the function block, or you create instances of it, or you call it in your program. You can only use these variables for your internal logic. So a function block is really reusable around my PLC program. Reproductions or instances or copies of the function block can be created. Each instance possesses its own identifier, the instance name, and a data structure, which contains its inputs, outputs, and internal variables. Instances are declared locally or globally as variables, whereas the name of the function block is indicated as the type of an identifier. So you could create identifier for every instances of function block you will create. For example, I have a function block with a batching logic inside it, or simply a motor control logic inside that block. I can just reuse this function block to my other applications. So instead of writing program logics again and again with the number of motors to be controlled with my PLC, I could just declare instances of my motor control function block. For example, I have 5 different motors to be controlled with my PLC. I don't need to recreate those logics for motor control. I just need to create copies or instances of that function block and named it with different identifiers. For example, this one is for motor 1, pump 2, pump 3, fan 1, and so on. So that's the definition of a function block. Next is function. A function is also a POU, but what exactly is the difference between a function and a function block? The answer is memory. We can describe that the function can often be formulas or equations and has no internal memory. It just processes the inputs and outputs, while the function block can be used as multiple instances and has internal memory. In addition, a result must be assigned to a function. That means that function name is used as an output variable. So when declaring a function, do not forget that the function must receive a type. This means after the function name, you must enter a colon followed by a type. To further understand the function, let me try to create one. Same procedure as before. Right-click on POUs folder, select command add POUs. I'll name my function sample underscore fun. Then select function as a POU type. A function returns precisely one data element. This is what I was talking about before, and whose call may occur in text-based languages as operator in expressions. The data element may also be an array or a structure. So in my function, I'll just select an integer data type as the return value of my function. Then click OK. Select the implementation language. I'll go with structured text and click on OK. Next is I would declare input variables of my function, example n var1 as an integer and n var2 as an integer. Now what I want my function to do is add the values of these two input variables. So in order to do that, I need to write that code in the implementation area of my function block like this. So whatever the value of those two integer variables, it always add up into the sample fun return element, which is also an integer. As an addition to function blocks in programs, we have what we call an action. So an action is a further implementation. It can be written in a different language other than the normal implementation, which is structured text, for example, here on the main program. And also each action gets a name. In this main program, I could add actions. We could describe these actions as sub-programs or subroutines, and that can be called here in the main program. Using actions is a good practice on maintaining your program organized. You could properly arrange your actions depending on what are the purpose of each one of them. So to add an action under the main program, just right-click on the main program, select command add action, and I'll name it digital IOS, for example. Select the implementation language you want to use. I'll select structured text. Create another one, name it analog IOS, and I'll add a couple more for interlocks and alarms, and I will use ladder logic as an implementation. So you could see, instead of writing all your codes in the main program and make it more confusing and very long to read, you can create actions as subprogram to make it less messy and easier to monitor, maintain, and troubleshoot. You can just call it all of these actions in the main program. Just don't forget to call, or else your action will not operate or run when the PLC is on run mode. An action works with the data of the accompanying function block or program. It uses the same input-output variables and local variables declared on the main program. So all the variables you have declared on the main program, you can use it in the actions under it. Okay, now let's proceed with the discussion on the programming languages. The Part 3 of the IEC 61131 standard deals with the 2 textual and 4 graphical PLC languages, which are instruction list, structured text, ladder diagram, function block, continuous function chart, and sequential function chart. I will focus more on structured text programming language, but I will be giving a brief definition of other programming languages and show you the basics on how some of it are implemented on TwinCAT3. I will begin with the most commonly used PLC programming language in automation industry, which is ladder diagram. The ladder diagram is also a graphics-oriented programming language which approaches the structure of an electric circuit. The history behind this is it replaced the conventional relay racks or relay logics and was developed into a PLC programming language that is really similar on the graphical representation of electrical schematics of relays. The ladder diagram is suitable for constructing logical switches. On the other hand, one can also create networks as in FBD. The ladder diagram consists of series of networks. A network is limited on the left and right sides by a left and right vertical current line. In the middle is a circuit diagram made up of contacts, coils, and connecting lines. The coils can be any inputs, switches from actual hardware, while the coils can be any actuators, pneumatic valves, relays, and lamps. Each network consists on the left side a series of contacts which pass on from left to right the condition on or off, which correspond to Boolean values such as true and false. To each contact belongs a Boolean variable. If this variable is true, then the condition is passed from left to right along the connecting line. Otherwise, the right connection receives the value of. Let me demonstrate how ladder logic is implemented here in TwinCAT3. Here I have added a new action called A01_LD, and of course the implementing language is ladder. What I will demonstrate is I will create a basic start-stop program for motors. First, I need to add a coil on the first network. You could add ladder symbols or ladder elements through here in the toolbar. You could see this FBD LDIL. So there's a bunch of symbols you can use. Another way is you can open the toolbox window, click on the view, then click on toolbox. So as you can see, it has all the standard operators, function blocks, and also the ladder elements. We could add the coils and contacts here. Another way to add ladder elements is by just right-clicking on the network you want that element to be added. Now I want a coil here. Right-click and insert a coil. So you could add a bunch of ladder elements here: a series contact, a parallel contact, a negated contact, set, reset coils, and also other function blocks such as timers, counters, and triggers. Okay, so let me just complete my ladder diagram. Now my diagram is completed. Next thing to do is to assign variables on each of the contacts and coil. So the variables that I will assign should be declared in the main program. Here I have already prepared the variables. So these are just Boolean variables just to show you how basic ladder programming is done on TwinCAT. I have a B start, B stop, B auto manual, B interlock, B fault, and of course B command for the coil. I can just copy paste the identifiers to the contacts and coil on my action below. After assigning the variables to my motor control ladder elements, the next thing to do is to call my A01_LD action in the main program. Okay, so now I'm good. Time to check for any errors. Click on the build project. And now I have no errors. It's time to load my project to the target device. Check if my target device is in run mode. This little TwinCAT icon here indicates that it is running. It should be on green. Okay, then click on login. The application was changed since last download. What do I want to do? Yes, I have made a lot of changes in my code and I would select login with online change. This will update the loaded program with changes I made during online mode and click OK. So now I'm currently in online view on my target runtime. My PLC program is running and I can monitor each of the values of my variables, each of the contacts and the coil. So what this program does, it is a basic auto manual control of motor. The first contact here on the left is the auto manual bit. It allows selection of the mode, whether it's auto or manual. If the variable is true, it will do this logic here, which is for automatic mode. And if it is false, which it currently is, when with this negated contact, it will execute the manual mode. Here in manual mode is a start-stop program. If B start is in true value and there are no faults, it will energize or turn on the coil. The B command will remain true even if the start bit becomes false due to the holding contact of the B command coil. So in the ladder, it's still basically relay logics. Anyone with electrical experience will easily understand ladder logic programming. To de-energize the B command coil, the B stop variable should be in true value because it is in negated orientation, or there should be a fault signal. Okay, so that was the manual mode logic. In automatic, we have a what we call auto request bit. So this bit can be activated on other parts of the program, example on program sequences, or it can be a percentage of level, flow, pressure. It depends on the requirement. There is also a permissive bit. This can be any signal required before energizing the coil. And if there are no interlocks activated and also no faults, the B command will be true or energized. The B command will only be deactivated if the auto request bit turns false or if there's an interlock or a fault signal. Okay, so that was the ladder programming in TwinCAT3. It was supposed to be a short discussion, but I think it's best if I showed you how to implement that language on TwinCAT3 due to its being widely used in the industry. And I also showed you how to write values on each variables during online mode. So basically, I showed you how to test the PLC program and do a simulation. Now let's proceed on the next programming language, which is function block diagram. The function block diagram is a graphically oriented programming language. It works with a list of networks whereby each network contains a structure which represents either a logical or arithmetic expression. The call of a function block, a jump, or a return instruction. It is similar with ladder because it also has networks, and the logic runs from left to right. The difference is it only contains block boxes that do Boolean operators such as AND logic or OR logic, and also math comparisons such as equal, add, divide, multiply, greater than, less than, and so on. Where there are several variables that can be compared can be seen on the left side of the block, and on the right side is the output. If the condition is satisfied, there will be a true value on the output of each block. Standard function blocks can also be used here, such as timers, triggers, and counters. I'll show you how to use FBD in TwinCAT. I've also added a new action named A02_FBD with the function block diagram as the implementation language. I've just added the A01 and A02 in my action names so I can properly arrange all of them under my main program. Okay, now the FBD is similar with ladder. You can add networks, and also the elements can be added via the toolbar above. You can insert empty boxes, assignments, and more. But there are more options in the toolbox. You could see here is a bunch of function block elements, Boolean operators, function blocks, math operators, and a whole other stuff more. I'll demonstrate how to create basic function block diagram and incorporate it with the previous ladder logic program. So in the ladder program, let me just go back in the ladder. Okay, I have here is the B command. We can say that this is a motor, an actual field hardware. So I previously discussed that this auto request bit, that it can be activated on other parts of the program. So we could use this variable all throughout the PLC project. So this time, I'll implement the FBD language for the automatic activation of the motor or this B command coil. Let's say I want to create a logic where the motor will run in a certain level of tank, a pressure of a pipe, and status of a valve. First, I'll declare additional variables on the main program. So for the tank level, I'll add n tank level as an integer. And for the pressure, I'll name it R pipe pressure as a real data type. And a B valve opened status as a Boolean variable. Okay, so going back to the FBD action, I'll use the toolbox to add FBD operators. I'll add a greater than or equal math operator. So this one will be comparing the tank level to a constant value. Then add an AND logic operand here. Add the operand for my pressure. Let's say we want to run the motor if the pressure goes below a constant limit. Then another AND logic operator for the open status of the valve. Next thing to do is assign variables to my blocks. So n tank level, Just copy paste it from the main program. Let's say a limit of 60 constant value. So when this variable end tank level goes greater than or equal 60, this block will have an output value of true. Then for our pipe pressure, I'll set a constant value of 15.78. Let's put it like that. When the pressure is below that number, the block will have also a true output. Then put my B valve underscore open variable here, and overall assign the output with the auto request bit on the ladder diagram. Then build the solution and download the program. Again, I am in the online environment of my runtime system. Now let me write some values on the variables. So to write values or to prepare values, just double click on this box on the right side of the variable and type in the desired value on the field. In here, the tank level, I'll write 65, a constant value. Then I'll set the B valve underscore open boolean into true and click on write value. Now the condition has been satisfied. We could now see that the B auto request bit is in true. Also here in the ladder, it means that this auto request bit signals the motor to run during automatic mode. With the satisfied conditions such as tank level is greater than the limit, pressure is below the set value, and the valve has an open status. So if one of those three status are not satisfied, then the auto request bit will have a false value. Hence, the B command will be de-energized or the motor will stop, for example. Again, that is in during automatic mode and if there are no interlocks activated and also no fault signals. Now let's talk about structured text. Structured text is one of the IEC PLC programming standards. It consists of series of instructions and it is also determined as a high-level language. The instructions are if instruction, case, for, while, repeat, and more. This is the one that me and my colleagues commonly use in programming PLCs in TwinCAT. Once you have understand it and begin to improve using this language, it really becomes an advantage on how to create codes that can be so simple and yet has a very effective approach. So you won't have to add so many networks, so many blocks, endless contacts, and endless coils. Also, some complicated programming can be easily done in a few lines of codes. Here are some of the expressions used in structured text programming. Okay, so a basic example of structured text would be like this. I'll use the permissive boolean tag and assign a true value. Type in the identifier or just paste it. Then a colon and equal sign. This is the assignment symbol. Next is the word true. Then end it with a semicolon. So what happens here is very simple. The true value will be assigned to the B permissive variable. Log in. Then start the program to run. And then there you go. You can see that it is in true. Log out from the online view. Now I would like to set it to false. Write false, then log in. You can see that the variable is now false. So basically, it's that simple. I'm gonna keep this one short. And on the next episode, we'll further discuss about structured text. For the remaining language, we just give a brief definition and examples of each of those language from the backoff website. First, we have the instruction list. So, an instruction list consists of a series of instructions. Each instructions begins in a new line and contains an operator, and depending on the type of operation, one or more operands can be separated by commas. In front of an instruction, there can be an identification mark or label followed by a colon. Next is the continuous function chart. So the continuous function chart editor does not operate like the function block diagram FBD with networks, but rather with freely placeable elements. This allows feedback, for example, two examples of network in a continuous function chart editor as they would typically appear. And last, the sequential function chart. The sequential function chart is a graphically oriented language which makes it possible to describe the chronological order of different actions within a program. Thank you for watching. I hope you learned much on today's topics. Feel free to leave a comment or suggestions below. In the next video, I'll discuss about the standard function blocks and the structured text operators. Have a nice day and keep safe. That's it for this video. If you want to learn more about Controtek Smarter Automation, you can visit our website at www.controtek.com. Subscribe to our YouTube channel and follow our social media accounts. See you in the next video!